This is the first video in AP Calculus for section 7.2 in our textbook, which is area between curves. All of the integrals that we've done up to this point have represented the area between a curve and the x-axis. So today we're going to be looking at when you have more than one curve and you're trying to find the area between them. So here I have an example of two curves, F and G, and we're trying to find the area between the two curves from point A to point B. So this first graph here shows the blue shaded region that we're trying to find the area of. So if we think about that geometrically, I could find the area underneath F from A to B, which would be the second picture here. But notice it includes all of this space right here, which I don't need. Well, if you look at the third picture here, that same space is the area underneath G from A to B. So the way that we can find the area between them is to integrate F from A to B and then G from A to B and find the difference between them. The question is, though, how do you decide which one should be your f of x function and which one should be your g of x function? Well, the one that has the most area underneath it from it to the x-axis is the one that should be the function that's the larger one, and then you subtract the one that's closer to the x-axis. So farther minus closer. So the formula then would be the integral from a to b of f of x minus g of x. Or if you had to, if it might make it easier on you, you could do a to b of f of x minus a to b of g of x. Like that. So that's how we find area between two curves. So we're just going to jump right in then. We want to find the area of the region here that's enclosed by the graph of y equals x squared, which is the red curve in this picture, and y equals the square root of x, which is the blue curve in this picture. Now, if we're looking at in relation to the x-axis, the square root of x is farther away than x squared is. So I know that my integral would be square root of x minus x squared. The question is, though, what are the boundaries of my integral? Well, I can see that this kind of teardrop shape starts here and ends here. So you can probably look and figure out that those x-coordinates are 0 and 1. But let's just kind of pretend for a minute that I wasn't sure exactly where those points are. Well, those are the 2 points where my graphs touch each other. So that would mean that is where the square root of x function is equal to the x squared function. So we would have to solve that algebraically. So to solve that, I would probably square both sides so that I could get rid of the square root. Squaring x squared would make it x to the 4th. So then if I bring the x over here, because I have to, because there's multiple x terms, I have to be able to factor that. So then if I factor out an x, I get x times x cubed minus 1. So x equals 0. X cubed minus 1 equals 0, which means x equals 1. So that first x coordinate is 0, just like we thought it was, and the second one is 1, just like we thought it was. Now it's just a matter of doing an integral. Like, once you have it set up, this is no different from the integrals we've been doing for quite a while now. So it might help to think about the square root of x as x to the 1/2. So then we can do the reverse power rule with it. So the reverse power rule, if I add 1 to that, that would become x to the 3/2. And then old coefficient divided by new exponent, that means that would have a 2/3 in front of it. The x squared would become an x to the 3rd with a 1/3 in front of it. And my boundaries are 0 to 1. So we would substitute in the 1 first, minus the 0, So this would become 2/3 minus 1/3 minus all that would become 0. So that total area of that little teardrop shape is 1/3 of a unit. That's that. That pretty much honestly wraps up the bulk of what's going on here. We are going to look at some things in different ways though, so you definitely want to continue to pay attention to what's going on. So here, again, we have the region bounded by y equals x e to the negative x squared, so that's that red curve, and y equals x plus 1, which is the blue line. The line x equals 2, so that's this black vertical line over here, and the y-axis, so that would be this section right here. So this whole green area is what we're trying to find the area of. Now you may think that that means that we have 4 things because they gave us y equals x e to the negative x squared, y equals x plus 1, x equals 2, and the y-axis. But if you pay attention to x equals 2 and the y-axis, those 2 things are vertical. So what they're actually creating are the boundaries for my integral. So the y-axis would be the left-hand boundary. That is when x is 0. That's another name for the y-axis. And then the other one is x is 2. So then it's just a matter of farther minus closer. So the x plus 1 line is farther away from the x-axis than x e to the negative x squared. So that's how I would set up my integral. Now already in looking at that, I can tell that x e to the negative x squared, if this was a problem that I was having to do by hand, which is how we're going to do it, that's going to require u substitution. But the x and the plus 1 are not going to need u substitution. So I'm actually going to, just for the sake of my brain, separate the things that are going to be easy to do and the things, I'm going to do that in a different color. The things that are going to require a little bit more thought. As long as I remember that I'm subtracting these integrals, it doesn't matter that I'm doing them separately. So we'll do the red one first and get it out of the way. X integrates back to 1/2 x squared. 1 integrates back to x with our boundaries of 0 to 2. So that's going to be 1/2 times 2 squared plus 2 minus 1/2 times 0 squared plus 0. So 2 squared is 4 times 1/2 is 2. 2 plus 2 minus all that's 0. So the red portion integrates to 4. All right, now the blue portion, like I said, I'm going to need u substitution for that. My u would be negative x squared, which makes du negative 2x dx, but I don't have a negative 2 in there. So that means negative 1/2 du equals x dx. So that makes this integral negative 1/2 e to the u du. But remember, when we're doing u substitution, if we change the x variables to u's, we have to change the x boundaries to be in terms of u. So we substitute our original boundaries of 0 and 2 into this u equals equation right here. So if we substitute 0 into there, negative 0 squared is just 0. And then negative 2 squared is 4, so that would make it a negative 4. All right, now we integrate that. So that's going to integrate back to negative 1/2 e to the u from 0 to negative 4. So that gives us negative 1/2 e to the negative 4 plus 1/2 e to the 0. So negative 1/2 e to the negative 4 is going to be negative 1 over 2 e to the 4th. E to the 0 is 1, so that's just a plus 1/2. So then we have to put the red minus the blue, because that's how the problem was originally set up there with subtraction. So that becomes 4 plus 1 over 2 e to the 4th, and then minus 1/2. So you could leave it like that. If it was multiple choice, they would, I don't know, 4 minus 1/2 would give you 3 1/2, so that's 7 halves. plus 1 over 2e to the 4th. They might try to make you get a common denominator. So the common denominator would mean multiplying this first fraction by e to the 4th over e to the 4th. So that would give us 7e to the 4th plus 1 over 2e to the 4th. As weird as that looks. And if you want to check it as a decimal in your calculator, that would be 3.509. But if this was a free response question, honestly, you could have stopped right there with your answer. But this might be as far as they would take the simplifying on a multiple choice question. All right, let's try another one here. Example 3. So no graph was given this time. It says to find the area of the region bounded by the graphs of y equals x squared plus 1 and y equals x for the interval from 0 to 2. Sketch the region bounded by the graphs. So what I know is that my integral is going to go from 0 to 2. The question is, which one gets subtracted from the other in terms of the two functions? So that's why I kind of need a picture here. So I only care about from 0 to 2. So x squared plus 1, if we substitute 0 into that, we'd have a point at 0, 1. If we substitute 1 into that, we'd have a point at 1, 2. And if we substitute 2 into that, we'd have a point at 2, 5. So there is x squared plus 1. And then y equals x, well, that would be a point at 0, 0. 1, 1, 2, 2. So there's my line. So the region that I'm trying to find the area of is between those two things. So that's that space right there. Now you can tell by looking at that the parabola is on top. So we're going to do the parabola minus the line. Now, I want you to pause the video at this point and see if you can find the total area between those two curves from here on out. I've done most of the hard work for you. All right, check your answer with my answer. Mine came out to be exactly 8/3 for the area between the two regions. So if you did not get 8/3 like I did, look at your integration and your number sense and compare it to mine. And that will wrap up the first video on area between curves.